I try not to stream. I can't, you know. So many things. I just don't got it right, you know. I need more coffee. More and coffee. Okay. Okay, I think I got the sound good. I got everything kind of fixed. I got this already pre-logged in, so we won't have the microphone issue. Let's jump into it. So today, I'm at the tail end of designing the ClipidyClapper. The ClipidyClapper. Look at that text. I'm pretty proud of these texts, right? So, where am I going to start here? Let's show you what I started out with. I had a cool idea, and I was like, those clap circuits are awesome, but I don't really want to mess with 120 volts mains electricity. I just want to turn on my LED lights. Really, my son hated getting up out of his bed for like night lights and stuff. No, sorry. So I went ahead and I made this for him. And this worked great. I'll show you. So let me switch over here. Okay, so we'll switch it over here. Hopefully you can hear me good. So we got this, there's an Arduino, there's a relay, and then there's this microphone module here. Again, it's pretty simple. I got a linear regulator here, steps down the voltage to 5 volts, and that powers this stuff. And then what doesn't go into this goes straight through the relay contacts and goes out. It's really simple. Right? The hard part is like tuning the microphone, but most of these LED strips here, and a lot of things, anything that really takes this barrel jack, it'll work for. I mean, it will go up to, I think this regulator goes up to 30 volts, but you'll see my next one has a higher range. So you just plug this into here. You can see, there it is. It's powered up, and I love that it's standalone. You don't have to like plug anything extra into it. All right, and then boom. And then it's just a clap circuit. Right? So turns on. Fair enough. Okay. So it's got this little microphone in here, which is actually tuned poorly for clapping. I got a better one in my next design because I designed this module myself. I was like, I'll make one myself. So we got an Arduino. Now this is a cool like beginner level stuff. I mean, I didn't really have to calculate like a switching diode or... It's just simple. I put a relay there. This relay is a 5-volt relay, which is perfect because this is a 5-volt board. But I wanted to use the STM32 family. It's a much better design. I could, and here we're just. So we're back over here. Now here's version 2. And, well, technically, yeah, okay, so version 2. So we'll look at the microphone module first. So, yep, get my own microphone module. Instead of the SMD, they use the tinier SMD. I use the DIP package here just for prototyping purposes. I try to use a regular trim pot because I have these Neo pots that have like LEDs in them. But no, I need an actual trimmer pot with more turns. So yeah, that is that. And instead of using an AVR family, the Arduinos, we use the blue pill. It's called a blue pill. It's an STM32. And then instead of the linear regulator, we use a buck converter, which you can tell the linear regulator, we just need some small decoupling capacitors. Do I even have 2? Okay, that's concerning even for this build. That could have... probably not would have handled spikes, but we got beefier caps here. Look at those. We got an inductor. Like this is a full buck converter here, much more efficient, much more stable. And then the STM32. Now this is all running off of 5 volts, so whatever you put into the input, it'll take 5 volts of that and power everything. This one is 3 volts. Now look at these LEDs. Once I found these, I ordered them. They're expensive compared to regular LEDs. But they just look like I just want to use them everywhere. These freaking cubes. Alright, so this runs off at 3 volts. Power that up. Now, same thing. turns on. Now this red one comes straight from, this is like the indicate, it's not, I don't need to do that because it is an indicator LED, and this one is the load LED, so that comes from the relay, so that would be the actual LED strip right there. So sometimes you miss one, you got to hit it 3 times. This yellow one will light up a little bit. Oh yeah, did you see that? Like when it's pretty much showing you that it's detecting sound. So yeah, so this is the ClipidyClapper. It starts with that, then it moves into this. What else? Oh yeah, see, this is the STM32 right here. Now I still don't need all of these pins, right? So my design doesn't use like most. I really just need a couple, and instead of this one using like logic to control everything, so what it does is it waits to hear the claps, and then it turns the relay on or off, drives the relay through this MOSFET here, no less. This one uses the interrupt pins. So this one, while it's always on, this one's a lot more efficient. This one does nothing, but once activity happens on a pin, it triggers an interrupt. So much more efficient. It just takes everything up a notch, right? So, and it actually is much more clear. It doesn't get like a lot of false claps. This one sometimes will turn on or off. It'll trigger when the TV is too loud. Because what the LM393 does is essentially on the output, it gives pulses. So you don't just get on when there's sounds. There is like a duty cycle. So you get pulses out. So you have to wait. You want to look at the edges. You want to see when's that first up edge, rising edge, and then you want to count a certain amount of time, and you want another rising edge to happen. So, okay, I think we're done with this. We'll jump to there. I think so far so good, right? So far so good. I think the sound is okay this time around. All right. Also, what I might need to do is turn this out. I just look at all these lights. These cubes. Okay, so we'll turn that off. I'm at the tail end of the schematic. I'm almost ready to start doing the stack up here, and actually routing all the parts. See, we got parts and stuff. Here's the PCB design. Now here's a cool thing. I actually added one of these components in this model. This one. This is the cube light. That was not in the EasyEDA library. So normally when you're doing this, you'll come down here and you might find a specific part, or like here we got a capacitor. We'll just click it there. You see it down here? That's the library. So I'll just come down here, I'll find the part. I might need to search it, but there was no part, so I made my own. And now there's the symbol, the footprint, the picture, and there's even the 3D model. So I spent all night trying to figure out how to add this LED right here, this one LED. Now, there is going to be this analog clap, which I actually don't use the analog clap signal, but I'll still route it to a pin, just cause, right? Like, why not? So where am I at now? So we got the crystals, we got the high speed. These are the external crystals. So we have the high speed and low. We got the decoupling capacitors. Power buck converter. You can see the buck is as a whole switching node right here, which I tried to color to make a different color here. What did I say here? Anyway, so, and then we got the actual clapper, or I guess the whole thing is the clapper, isn't it? This is the microphone circuit. Should I change the name of that? Because I guess the ClipidyClapper, all of this is the clapper, right? Or is just, should I, this is the problem with designing things and naming them. And also, for no particular reason, the only I rarely get the chance to use resistor arrays, so I use this little double resistor array right here. One goes to the LED, sinks into the output of one of the op amps in there, and then yeah, so. And then another thing is on this trim pot, this 10K pot, I may consider adding a larger potentiometer over it, and sort of like that way, I want it so a person can adjust the sensitivity of the microphone. You know, sometimes you want to adjust the sensitivity. Ooh, you know what else I forgot? I want to bypass all of this too. So I gotta go and I gotta add some switches right now. So we'll get into this. Okay, so right here is the relay. So let's just create this. It's just how are we gonna do this? Let's just draw a little box here. Ooh. Okay. We'll do that. So I want to add a couple of switches on here. We'll add the relay in here though, in this box. So I forgot why I put this lone capacitor right there. Well, I guess we'll just put them right there. Also, see if there's any changes. Yeah, I did change some parts out. I think we're going to be able to keep this fairly small. I mean, if they're spread out now, but the only thing that I'm concerned about is the power stage, the buck converter, which I think they wanted about, I think it's like 2 square inches of thermal relief for the buck converter. The buck converter can get pretty hot. So I'm going to try to go thick on that pour. What is my stack up right now? Top, bottom. Okay, so I'm on a 2-layer stack up right now, which I might be able to get away with on this. Honestly, I think that's what I'm going to do. Is I'm going to try to go with 2 layers, and just have it a single side PCB, and we'll use the other side for ground. Right? We'll just ground plane it, and then whenever we need to, we can cut through. The only problem is I don't really want to break up the ground plane like that. I might do a 4-layer board and just have like signal, ground, and power. Ground and signal. How does that sound? Any engineers out there? Can you hear this? If you hear that, so how do you think of that stack up? We go signal, ground. Sorry. Yeah, signal, ground, power, ground, ground, signal. Alright. Okay, another thing that I'm not the biggest fan of is this right here. On mine, on these boards, they kind of come out a little bit right there. See that? I don't want it to be flat with the PCB. But then again, when I 3D model an enclosure for it, what I can do is, let me turn the mic down a little bit. Looks like I'm redlining. What I could do is create like a horn shape on it. right? So, okay. Okay, let's see, so if I switch back and forth here, pretty sure you can see this. So here we go. Where am I at? Okay, so I got the relay. I need some, did I have some switches pulled up? What's this? Oh yeah, I need to find an alternative to this guy to switch the relay. I like that because it looks white. Is it white? Is that white? Alright, let's look at the data sheet here. It's not white. It's just a, it's like a weird picture of it. Oh, does this have two comparators in it? I think this has two comparators in it. Alright, let's see. Let's see, distance. Oh. Okay, this device consists of 4 independent precision voltage comparators and offset voltage specified 2 millivolt max. I don't think I've ever used one of these before. Supply voltage. That's a lot high. Wait, hold on. PCC. Voltage. And this thing could take just 18 or 30. Okay, this has 2 versions. Alright, we'll get off track. I'll scratch that itch later. We'll get rid of you. What we got here? MOSFET. Which I decided not to go for the MOSFET. I have a MOSFET on the Arduino version. Okay. Watch my power here. Switches. Relay. Just like, what should I look? Tactile. Alright, so this one is going to be for, we'll do a reset, and then a boot. I'm pretty sure, jump in the data sheet here. Boot pins, I use to select one of 3 options. Okay. Okay, boot 0, yep, that's what we're looking for. Okay. But we don't want to know where it is. Oh, there it is. Pin name. Pin definitions. Let's continue on. Oh, it's 5 volt tolerant. That's interesting. Is that right? IO max 5 volts. Yeah, that's a 5 volt tolerant pin. FTIO. What is FT? Okay, we'll look at that later. See, you could go through these data sheets and just learn so much. Electrical engineering would be nothing without data sheets. It's all data sheets. Everything is data sheets. The formula to figure out what your decoupling capacitor should be. Okay, maybe that's not in there, but sometimes it is. But wait a second. All IOs except high level input need general input. Spread the parameters given to the hard drive from test performance conditions. Blah, blah, blah. Wait, I don't have. I think it's safe to assume that when it's 0, it's good. Hold on. Boot. Oh, actually, you know what? I have a. It's the LED. That I love. If you want to get that LED, there it is. DigiKey. How much are these? They're 32 cents each. 32 cents each. Alright, so. Alright, here we go. So, boot 0. Boot 1. I didn't use a boot 1. I do notice sometimes there is a boot 1 on these, but I don't need it. Okay, so yeah, so let's look for, we need a 3-pin header for that. Let's get the headers done. What should I do? I was thinking of having a button though to press, but then you have to hold it. Do I want a jumper or do I want a button? I just really need it like one time to program it. So what I'm going to do is, yeah, I'm doing a button. 250 GF grams. No, we don't need a heavy one. I do want something that I could hold down though. Something that will stay. Or I could use, hold on. This is the hard part of design. What would I, normally I would just do a jumper pin, but I kind of want things to be small. So I want single pull, single throw switch. Is that a toggle surface mount? Ooh, that's sort of what I want. Oh, I like the all black. Do you even got them in stocks? Yeah. Ooh. I mean, I know it's not that big of a deal, but you know, black is nice. Wait, let's see. Can I change the color of the PCB on here? I can. Because I think I'm going to do black anyways. Coppery. Ooh. Ooh. Sexy. Okay. Purple. That's what I was thinking of doing, was doing purple or black. Definitely not yellow. No, not yellow. I don't like yellow. Red is very nice. I want red. No, I don't want a red PCB. I want blue and green. Yeah. White. I do like white. Nah. I think we're going to stick with black or purple. For now, I'll keep it black. Just for now. Keep the pad silver. Because I want to try to keep the costs down. Alright, might change the stack up a little bit, but okay, this is just, the parts are just thrown in here, just willy-nilly. I mean, this is going to be a lot smaller. Let me just throw these parts closer together so you can see. I mean, this thing is, I'm going to really push it to the max too. Yeah, I'm telling you, I'm going to make this thing tiny. Alright, I'm just randomly throwing it. Don't read into what I'm doing too much. I just want to see the size. Throw that LED right here. The inductor is going to be close to there. I'll do that. I'm going to have to redo all of this, but whatever. There. Alright, let's see what that would look like. Watch, blink. Yep, much better. And it's going to be even smaller than, actually, you know, I might, because of the power, this is probably more realistic. It's going to be about this size right here. Oh, no. I need the DC. See, I don't know if I'm going to actually put the DC barrel jacks on the PCB like this. What I think I'm going to do is expose pads so that I can have panel mount ones. Hold on. But so yeah, it's going to get a little bit bigger because I do have some more parts to put in. All right, so let's see, single pull, single through, dip. Let's see. I want to toggle. Okay, no. Okay. What am I? How? Okay. Toggle switches. Here we go. Too big. Can we get SMD? No. Okay, hold on. We want to look for a tiny one. These are all big. No. We don't want toggle switch. We want, oh, here we go. Configurable switch. Maybe like a dip switch. Actually, that might be, yeah, we'll look at that. Ooh, navigation in, limit. I don't think I'm going to do a push button. Maybe a slide switch. I'm okay with that. So the toggle ones are too big. A thumb wheel. I don't know if there's a latch selector. Dome. Okay, it's a good our options are here. I really do like these. If I could find a double pull, or sorry, like a double. Let's see. We got 2, we got 4. 2. There we go. Right there. Now do we go tiny, tiny? Like that. Like that. How much? 18 cents? That might be our guy right there. What's these? These are the same thing? Okay, those are the same thing. Then we got these little, these guys, which are tiny, tiny. Maybe a little too tiny for me. See? Surface mount, 4.1 by 5.4 inches. Ooh, we had a single. What do we need 2 for? We don't really need 2. Oh, yes, we do. We got 1 for boot. No, we just need 1 for this. 1 for boot. I do want another switch to turn on the microphone or off, but I'll have a bigger switch for that. Ooh, that looks cool. Oh my god, 16 positions? Take note of that for later. Alright, so here's a single. I think we'll use something like that. It's got to be it. Okay, so alright, so we got 2. Wait. Okay. You think here. I really like this one. I don't see why I wouldn't use it. Oh my god. $4. Hold on. Hey, do I need to turn that off? Okay. Okay. Oh, it's a little pricey though. It's a little pricey. Let's see. $5 I'm spending for this? Okay. What's the difference here? It's not much of a difference. It's like the same thing. Okay, hold on. Number of positions. Let's see, what am I looking up here? So we got, okay, we can get rid of that. So we're going for one of these. Let's see, 271. Okay. First, but okay, that's half the price. That's what we're using right here. So what I'll do is I'll add it to my bill of materials. I'll copy the part, throw it over onto my other screen. Come over here. Let's throw that switch. Uh-oh. Oh, wrong library. Right here. So, 1, 2. Which one's 1? Which one's 1? Which one's 2? Can I see the pins? Which one's 0 and which one's 1? Okay, wait. Let's do it like this. I'll put Oh, this won't work, will it? Yes, it will. So what I'll do is I'll tie it. So I need a 100K resistor. Do I have any resistors on here? Okay, yes. So I'll have a, oh no, I don't have a regular 10K because I used the array. Okay, okay, let's go to my list. We'll go to my other resistors, which I use these Yagios. I could use 100K pull down. You know what? I'm gonna use 100K pull down. Would that be enough? Let me look this up. Let me take this. 3 volts. Sorry, let me do some math here. If I have the STM, what did I say? 100K. Is yeah, I think that should be good. I think that is that the equation? 100K. Okay, no. I mean, it works, but it's a bit weak. Okay. I probably shouldn't have used that relay array, but whatever. Okay, what's going on? Let's see, 10K, 0402. Okay, so we'll use this guy. And also, what is my other? Let's see. No, not that. RC0402FR Is there KL? Yep, same. Okay. So we'll add that to the bill of materials. Copy, kill you. Throw that up in my bill of materials wall. Place. So how we'll do this is okay, and then we'll go up to boot. Where's boot? Here it is. Yeah, I should call this boot 0. And then I don't like that it's like the opposite. Hold on. There we go. Oh wait, what's not going on here? Oh, it doesn't like that. Okay. Short. That way I can get away with it. Oh no. Okay. Okay. We'll also make this a lot smaller. There we go. I like that better. No, I don't. You know why? Delete that. We'll delete that. I know I'm nitpicking, but I want to go left to right. So I'm going to instead go like this. Ah. There we go. Can we make this smaller? Yes, we can. We can fix this. Still. Back in. There we go. There we go. And then this, which one do we even need that? I guess we kind of do. Okay. So now we're about to find out. On. So 0. Okay. My brain. Okay. On. And then we switch it to 1. Yeah, that works. And it even says, is it normally open? Or is it on? Normally open? Or on? Who knows? Okay. There we go. Okay. Shadink. Oh. I can even move it closer. It's gonna look cool. There's no traces on it. Once you get traces, then we start looking nice. Okay. So there we go. We got our boot 0. Can we not? Can you not? There's some room for the title. Okay. Probably don't even need this yet. Okay. So we got the boot 0. Now we're going to need 2 UART pins. Okay. We're going to need a serial wire. So we're going to need 2 for it'd be nice if I had 4 pins, right? And it was like ground. This one's ground. This one is your VCC. And then these 2 could be UART, RX, TX. But then you could switch it. And then these would go to single wire and clock. Single wire data, SWDIO. And then single wire clock, SWCLK. The only problem is I'd just be too many. I'd have to route and trace things. So we're not going to do that. We're just headers. Keep it nice and simple. But I do think I'll do right angles. I know there's colors in here somewhere. We want headers red. Okay, I know I have them in here somewhere. Here, hold on. Carts and favorites. Yep, see? Oh, but those are males. I want females. Like that. .5 millimeter. I mean, is that much different from 2.45? Because that's normally what it is. Hold on. 2.5. Okay, give or take plus 10. So should I do that? I really don't need to though. That's the only thing, is I really don't need to. I'll just have pads. Yeah, I'll just have pads. Okay, so we got that and that. We're probably gonna need a power LED. So yeah, let's do that. Let's jump in here and do the power. Oh wait, hold on. Let me look at this schematic right over here. See what he does. So I already got that. I got the reset. How does he do it? Oh, I don't have the reset yet. I do need a reset, which, yep, we'll do a momentary switch. So we want momentary. Ooh, I like that. I like these, but the knob just keeps getting bigger. Okay. You know what we're gonna do? We're gonna do something like this, because I know I got these. I know I have like almost these exact ones, but let's go tactile switches. We don't really need JSTs, we got those already. We will need one of these. But what's up with that? Yeah. Yep.
Can you order a burger or a pizza?
Not right now. We can go out. 12-volt mount. Okay, I see. That's why it's a double. Wait, but it only has... Oh, it does have 6 pins. Okay. So probably got to go out, go grab some food. I have a bunch of those. I like these side ones. One amp, 6 volts. Okay, let me think of this. Yeah. Pretty much all we're doing is I have to update my code a little bit, but what I could do is when this is high, we'll use the microphone, and when you switch it to low, it'll just turn the it'll just flip the relay. Yeah. So we'll do that. I like this. I like this little side guy. It might be a bad idea. I've never used one of these before, but how much is it? 62 cents. Boom. Throw that in. Get the little guy some food. So I'm just going to drop this in. Let me see. Okay, it was a little big on the schematic. Okay. So let me just make sure. Oh, thanks. There's not much there. 3. So we got these two, this one, but there's not really, oh, okay, it just shows circuit diagram. It's literally, okay. Okay, so this is how we'll do it. This is how we'll do it. I'll have to change the code. Maybe what I can do is, do I have it open? Make sure I don't have it open somewhere else. Okay. So let's turn on another pin, and we'll have that called the enable, right? We'll have it be an input. And we'll call this one it'll be called mic enable. Okay, so we have it on input mode. Yes, do we need I think it would make sense to have a pull up. Module. Let's look at the data sheet here. Where is it in here? So what I can do is, I don't need an internal pull-up, right? Because I'm tying them to high or ground, but that also means that I'll need to route to ground. So I'll do an internal pull-up. Let me think here. Loading a that should work. What is the STM internal pull-up? So for some manual toggle switch, this is usually fine, but it's not as robust as hard. Sorry, pin. Gotta verify. All right, I'm not gonna do it because it's too weak. It looks like they're too weak. It could work potentially, but I'm not even using pull-ups on any of these. So okay, so let me save this. I'll just generate the code here, just so it's in. Let's see, should I use a 100K pull-up on it? Open the project. 100K. let's see, I might want to add either a pull down or pull up. Oh, okay, let me see here. Okay, so that's pin 6, but now we have pin 5. Which we are going to call mic enable. All right, and mic enable. It's going to go like this. Going to go right there in the middle. All right, I'm going to do it. I'm going to add the pull down. So, we'll do this, and then right here, we'll add and then for these guys, we don't care. We just need them soldered. Okay. Okay, so here's the mic enable. Again, I don't know, we'll just put it here. Now we just need, what, one more, which is reset. Reset and that's it, right? Because the other things I'm just exposing pads. Oh, I might need a LED light. I don't need a user LED though. That's fine. Ooh, but I do have this load LED, which I'll do like this. And then we'll grab one of these. What is the value? Brown, black, brown. Huh? Nope. Oh, I know that band. They came to chill over at my house. Oh my God, that's crazy. They stayed at the Airbnb. Okay. Anyways. Brown, black, brown, brown, black, brown, gold. 100 ohms? Really? That's what I'm using? Hold on. I think I'm going to go more than that. What is this? Red? Orange black? 23, okay. So we're definitely going to want more than that. Oh, there we go. $23. Okay, you know what? Black, brown, black, brown, brown, black, brown. Ah! 100. Let's do it. Let's do 100. I mean, I could do the 150 just because I already have one. Yeah, we'll do that just to keep it cheap. I got the 150 right here. All right. There's that LED. Oh man, am I running out of room? Because I use this. Okay. So we'll do that. Is the load LED, and then we need the power LED, which is, where should we take it? We'll just take, we got mic enable, we got boot 0, reset, and then we also need reset. Hold on. Okay, almost there. Boom. Okay, let's just do this real quick here. Where's those black ones? Where's the black ones? We want the black. Oh wait, where'd I put them? What do we do here? Single pull, single throw, that's all we need. This one seems heavy, 400. I mean, I guess I do want it to be a little heavy, but maybe like half that, like 200 grams of force. 250? Yeah. Yeah. There's so many choices. So many goddamn choices. I don't know. I guess it does. I'm going to do one that I know I have. I have I have those, but where are they? No. We'll just go with one of these. 60, yep. That's what I'm doing. Okay, boom. 51 cents though, kind of a little expensive. Hold on now. Before I add this, before I add you. Alright, I guess it's not crazy expensive. But we can cut it in half. Omron, right here, hot. 153. It's an easy to press button right there. We'll go with this one. It's going to be our reset. Save. Throw that over. Alright, how does... Do I need to pull up on it? On reset? Yep. Oh, we got a debounce and pull up. 10K pull up and a 1 microfarad debounce. Okay. What? 10K, yep. Okay. Let's grab this. I'm running out of room. Get this LED over here. All right. Boom. Wait. Pull up. Yep. And then we need the 1 microfarad. Oops, let me unplug that. We want 1 microfarad. And which ones am I using here? We want to kind of keep it in the family. Murata. Murata, here we go. It's 0805 though. The family. 0402, we're going small, that's right. Right here. 1 microfarad. We got a 0201, that's even smaller. We don't need to. We won't go too crazy. And we'll just copy that, add it to our project. Good debounce. Boom. In fact, we're going to do it like this. We're going to tie it to it like that. this over here. Oh, I still got a couple more steps to do, don't I? Darn it. Alright, I'm not as close to finished as I thought I would be. Let's see. Is that close to what he did? He did put his cat more closer to the pin. Oh yeah, I did the same thing. Okay. I don't have a power LED. I don't really think I really don't care for it that much. Alright, so let's put reset here. We do have a load LED. Now what I could do is copy paste. I was thinking of doing an LED on this. So I'm going to press this down. Turn an LED on when I press reset, but nah. Okay, I could actually delete that one. And instead of load, I could just say VCC 13. There. It's kind of a long name. Okay, there we go. I want to put labels and stuff on this later. So, okay, so we got reset, we got our boot, we got our mic enable, we got a load indicator light, we got our power indicator light. The next thing, really all we need to do is turn this guy on. So we need a flyback diode and a NPN transistor, which N2N4401. Hey Micah! Micah! Get dressed if you want to go out and get food soon. I'm almost done. Alright, well get dressed please. Alright. We're going to get ready to go eat soon. So, all right. 2N4401. Okay, that's right. All right. 2N4401. Didn't I already look this up somewhere over here? What's that? It's that little switch. Oh, yeah, these are these guys. What's that? A selector switch. What? It looks like a resistor array. What? Can we translate this? I don't know what the hell it says, but it looks like it's like 360 degrees. Does this like turn on if you rotate it? Is it like a reed switch? It's almost like a reed switch. Oh, here we go. Okay, so let's get this. We got a little function right here. Okay, so oops. Oh wait, they got a SOT 23. That's what I want. That is what I want right there. Let me just make sure. Base. Wait, that's emitter to base voltage. What is the base to emitter? I have it on here right now. Can't see shit. Can't see shit. Okay. Oh. I actually have a 2N222. This should work, but you know what? I just keep things simple, because I know these will work. Wait, what? Is that a 4-pin? No, it's a 3-pin, okay. Current. Let's see, on characteristics. Okay, what is the base resistor that I used? We're going to use that, and then we're going to use brown, brown, black, black, brown. There's no way it, wait. Maybe I'm looking at it backwards. Sometimes I look at it backwards. That's probably more like it. Alright, you know what? I don't like that number. So what I'm going to do is, I'm going to use that part. This is actually pretty cool. That there's a 3-pin version. It's, oh my god, look at that price. Never mind. Never mind. We're going to go with one of these. That'd be cool though. 50 volts, but nope. Okay. We'll go with the 40 volts. Alright, we'll use this. Add that. I didn't add that to my other one, did I? Make sure. Nope. Okay. Good. We'll use this. That's perfectly fine. Then we want to grab a series resistor, so instead we will do it like this. Wait, instead we will go, we'll go here. That. There. Stay there. Oops. And then load pin. No, I want it to be something like that. So like that. Come on, we're running this. We're freaking speed running it. We're speed running it. Okay. Oh, we need at least a 2K. We'll do it 2 point something K. Oops. Freaking. Oh, did I just undo something? Okay, nothing serious. What are these? These are all the little dub resistors. Okay. Let's go to here. We'll go to passives. We'll go to resistors. We'll go to chip resistors. Surface mount. We want about a 2K ohm. I don't know what I got, but we'll do. We could do more. We don't need to saturate it crazy. We want to saturate it a lot. 1K is probably aggressive, so instead we'll do a 2.2K. And what are my parts are coming from Yagio. Yagio, oh, that's my son's. Okay, Yagio. Okay, 142 right here. We got 1%. That's a great guy right there. Add that in. I don't even gotta do no math. Boom, save it, throw it in. This is our series resistor, our base series. Can we, I guess that didn't really. I'm going to throw our designators over here. I'm going to throw this guy right here. Connect it to here. Then we want to, we want to do something, right? All right, we want to come in through the collector. We're right about to. We're about to go. Boom, right here. There's our emitter. There's our relay. Let me make sure this is right. These are going to go to the barrel jack. So now I'm going to just do pins. That's right. So the barrel jacks can be soldered on later. What am I missing? Oh my God. That's it. That's it. We're good. I'm going to clean this up, you know, because I have all these like the labels and everything. I'm going to try to tighten things up so I can make the schematics look clean, because why not? I like clean looking schematics. You know, we can select all this stuff. We can kind of squeeze stuff in here, make some room. You know, we can throw crystals up here, and then we can even add a group. We can just say crystals, and that way once I add these to a group, I can't like mess it up. If I grab one piece, everything's coming with it. Okay, now let me make sure this is correct. We got the load pin coming through a series resistor. Oh, I can pull it down. I want to pull it down. Yeah, why not? We want to pull down. So we want like a 10K. Keep it nice and clean, right? Have a pull down resistor on here. Boom. There we go. This can be tighter. Okay. So we have this as a low side switch, which is good for an NPN. Even throw a label in there. Okay. All of this. Relay. All of this. I could separate this into like the logic and the power, but no need. Okay. let's see, let's look at these schematics that I'm using as a reference. Ooh, I want to pull down. Okay, I want to pull up the clock, pull up, and pull down the data line. Okay, let's do that. Let's pull up the clock and pull down. What are they using? 10K is great. Okay, so we want to pull up the clock. Oops. Oops. Let's do that. Let's kill that group. Let's do it like this. Boom. You're pulled up. And then you get pulled down. These guys are going to need to do something. Alright, so we'll just pull that down. It's a little messy, but there we go. So now I pulled up the clock. Just trying to line up everything. All right, that should be good for now. We're gonna go out to grab some food. I'm pretty happy with this though. You can maybe fit some of these in here. Nah, I don't want to fit that in there. I like this kind of straight up. Maybe I can fit the boot in there. Yeah, that fits in there. Get in there. Get in the boot. You can't fit. You go down here. Okay, you know what? Stay where you were. You can scoot ski potatoes on down here. While you guys whoa. There. There, good enough. That saved a lot of room. Wait, can I fit that in there now? No. Okay, that's fine. We'll just put that there. This guy we could also put in there. Ooh, that's sexy. That is a sexy reset right there. Look at that. Woo! Can I put this in there? No, we can't. But we can put it like that. So that. Yep. All right. All right. That's it. We'll put this out there. Design that. Let's see what other parts we put on here. Put a bunch of parts anyway. Yep. Put some LEDs. Let's take a look at it before the design. There we go. It's nice. All these will be Stutski potatoes over there. Oh wait, hold on. This is gonna be the cool part. All right. Let me just. You. Okay. You. Oops. Okay, I'll put this button right here, but this is the part that I want to see. Okay. Okay. Now watch this, watch this, watch this. Is this the copper area? No, wait, where's the board? Oops, is that the wrong? That's the wrong rectangle. Oh, here it is. Wow. Oh, should we go for like a different shape this time too? Wouldn't that be cool? So if I went like, if I did something like this. Right? Right? All right, here we go, before we leave. Ah. Okay, it's as a little stupid, but look, this is the cool part. This switch right here. It's hanging over the edge. It's hanging over. I don't know, these pads, that might be a problem. I gotta look up JLC PCB's design specs, if they can even do that. And just look at these cube LEDs. Oh my God, they're so cool. And I'm gonna put patterns on there. I think I can scrunch that up a little bit more than what it is. But I do like that the microphone's gonna be like on the edge. This cap, oh my God. I might wanna look at some other capacitors, see if I can find a smaller one, but that's the input cap. So I do kind of want it to be a little beefy, but that might be a little too big. Is that the input or the output? 680, yep, that's the input. And then we have the tantalum for the output. That's the C11. And I'm going to redesignate everything too. And look at these are the crystals right here. This crystal and this is so much smaller than the regular crystal that I would normally use. I hope they'll work. I mean, the specs, the capacitance, low capacitance and everything is the same. So all right, Not that many through-hole components. It's gonna look so cool when everything's traced and like actually designed right. But that's it. I don't know how long that was, but that's it. That's the schematics are now done. I'm gonna rearrange this. I'm gonna get some food in me, rearrange this, make it look a little bit more pretty. And then I'll get to start stacking up and routing, placement, routing, all that stuff, all that good stuff. So stay tuned. There you go. Got any questions? Ask them. Have a good one. Much love. And I'll see you later.